Hello learners, I greet you all and welcome you to yet another lesson of mathematics, and thank you for following these lessons as you keep safe in this COVID-19 pandemic. Please make sure you keep following us and learn so that when we come back, we can all be on the same page. Our today's lesson, we are still talking about algebra, and most importantly today, our main focus is on collecting like terms together. And as far as collecting like terms together is concerned, we need to look at some of the important facts that will help us understand our main concept. And one of them is that like terms are terms with similar variables. The other time we talked about what a variable is, and this is what we normally call the unknown. So we're saying that like terms are those which have got the similar variable or variables. In this case, we're talking about the unknown. And our examples here, we have x as the variable, then we have 3x. Our variable in this case is x. So because this one is x and this one is x, these terms are like, irrespective of whether they have the same coefficient or not, but as long as the unknowns are the same, those are taken to be like terms. We also say that 2xy and 8xy are also like terms. Why? This is x, and this is x, this is y, and this is y. And definitely, when they are like terms, we also have unlike terms. In this case, if we have x and 3x, these are like terms. But if, for example, we have x and then we have 2y, because this one is x and this is y, these ones are unlike terms. In other words, they don't have the same variable, so we have no reason to call them like terms. Our focus is majorly on like terms. We also say that similar variables with the similar exponents or powers are also like terms. Similar variables or unknowns with similar exponents, powers, or indices are also like terms. Here, an example is 3x to power 2 and 2x to power 2. Because this power is the same and x is also the same, this is x, the power is the same, these ones are also like terms. We are having here 3x to power 2. This is 3x, but the power is 2. This is 3x, but the power is what? Is 4. Now that the powers are different, however much the variables are the same, these ones are unlike terms. Because what will be here and what will be here if you substitute will be completely different. It is for that reason that we are looking at these two as unlike terms and these ones as like terms. So when you're collecting like terms, these ones are deemed to be unlike terms. We also say that when collecting like terms, every term should retain its sign. It is important to know that when you're collecting terms, every term should have its sign retained. If it is a positive integer, it should remain a positive integer. If it's a negative integer, it should remain a negative integer. Bearing in mind that the sign of the term is that sign before it, not after it. It is also important to note that when we are collecting like terms, we always deal with positive terms. Remember, we are going to be having terms that have got different operation signs. We are having addition, we are having subtraction. It is important that when you are carrying out terms, or when you are carrying out collection of these terms that are having different operations, you remember to always use the modulus, which tells us always add first and then subtract last. It is for that reason that we always want to deal with positive terms and end with the negative terms. Let's look at some of the examples. Bear in mind all these procedures or all these important things to note. Let's now have some examples. Our first example is saying simplify 3y minus 4x plus 2y plus 5x. The first important thing to do is to identify the like terms. Which terms here are similar? Remember we have said that terms are like if they have got the same variable. Now that here we have 3y and here we have 2y. This is y and this is y. How much the coefficients are different, but because these variables are the same, these terms will be similar. So this term and this term are similar. We are saying when collecting like terms, every term should retain its sign. So this 2y will retain this plus as a positive term. Then this one also, this term which is negative 4x in this case, and this 5x which is a positive will also be like terms. So in collecting like terms, we shall have these ones together and also have these ones together. But it is important that whenever you are carrying out any operation on terms, always retain the first term as the first one. 3y will be retained as the first one because it is onto this that all the operations are being carried out. So in this case, we shall have 3y. After having 3y, we are bringing 2y in its sign. So it will be plus. So it will be 3y plus 2y. Then after that, we have negative 4x and positive 5x. We are saying that it is important to always begin with the positive terms. So in this case, instead of beginning with 4x, we shall begin with 5x because it is the one which is a positive. So here we shall say plus 5x. After that, we shall say minus 4x. So here we have collected like terms, but the question says simplify. So after collecting the like terms, it is important that we simplify this, whereby when we are working out this, the terms are already collected, we always work out their coefficients. When you are collecting or when you are simplifying these terms, always simplify the coefficients. This is 3, this is 2. So simply add the coefficients. What is 3 plus 2? This is 5. So here we shall have 5, and then we retain 1. In other words, 3y plus 2y is 5y. This is similar to like saying 3 yams plus 2 yams. What's the answer? That's automatically 5 yams. So 3y plus 2y will be 5y. Now, when we come here, remember we are dealing with integers. Integers and algebra are inseparable, so make sure you go back and revise integers. Here we are looking at positive 5 and negative 4. So before we bring here the answer, it is important that we use the mapping method so that we can have the best answer possible. Here we are having 5 positives. So on the positive side, we shall have 5 of them. 1, 2, 3, 4, 5. This x is a negative, which is negative 4. So we shall have 4 negatives. 1, 2, 3, and 4. So this one goes with this pays this, this pays this, this pays this, leaving us with 1 positive. So in other words, from these two, we shall get a positive x. So before we write the sign which is here, we need to first work out this to get the right integer sign is right. So here we shall have plus x. It is 1x, but in the algebra, it is important if the value has got its coefficient as 1, we simply neglect the coefficient and take the variable. So in brief, this is 5y plus x. Now let's look at these terms. This one is y, this is x, and these like terms. Automatically, because the variables are different, these are like terms. And because they are like terms, they are incompatible. In other words, you cannot add them together. This will be our final result. Let's look at another example. Simplify. 3m squared plus 2 plus 5m squared minus 2x plus 2m. Simplify. 3m squared plus 2 plus 5m squared minus 2x plus 2m. What are the like terms here? First and we are saying this one is m, this one is m, and this one is m. Are all the three like terms. Looking at this important note, which says that similar variables with similar exponents or powers are also like terms, meaning that those that have got different powers are unlike terms. So in this case, this is m squared, which means the power is 2. This is m squared, which means the power is 2. We are not looking at their coefficients, we are only interested in their powers. So because this power is 2 and this power is 2, then these two terms are like. However, this one is m, which has got the same variable as these ones, but because it doesn't have the power, remember, any term without the power has got the power of 1. So because this one has got a power of 1, a certain power of 1, which is different from these two, this one will be unlike to this. So the right terms here will be 3m squared plus 5m squared. These ones will be like terms. Now, this one is unlike to this, but we shall deal with it and have 2m because it's a positive. After that, we bring minus 2x. It is important that we begin with the terms that have got variables and end with the constants. It is not in order to begin with the constant in between the variables. That's why we are beginning with this, which is a positive, this one, which is a negative, and then we shall end with 2, which is a constant. So of these ones, which terms are converted? That's the automatically 3m squared and 5m squared. This one will not be added to this because it is not similar to them. So here we shall have 3m plus 5m squared, 3m squared plus 5m squared. We have said we add the coefficients. What is 3 plus 5? This gives us 8m and then squared. The power will be retained because this is just a single term. Then plus 2m minus 2x plus 2. In this case, none of these terms is similar to the other. Therefore, we shall stop there. That will be our result. You can also look at this. Simplify 2y minus x squared plus 3x minus 2y plus 5x. Simplify 2y minus x squared plus 3x minus 2y plus 5x. So in this case, we shall identify the right terms. This is 2y, and this is 2y, which means these two terms are similar. Since they are similar, we can bring them together, and we begin with 2y. We have said every term retains its sign, which implies that the other 2y will come as negative. So we shall have 2y minus 2y. 2y minus 2y. Then here we have x squared. This is 3x. This is 5x. Are all these terms similar? Automatically, because this one has the power of 2, which these two do not have, it means it is not similar to them. So we shall begin with these that are positives and have plus 3x, then plus 5x. And then after that, we shall say minus x squared. After that, after correcting the right terms, we can now simplify. 2y minus 2y. We have said we deal with the coefficients. What is 2 minus 2? When we subtract 2 from 2, our answer will be 0. Now, in this case, we shall not say 0y. Because we have remained with 0, it means 0 is in the wrong, and y is in the wrong order. And in this case, we no longer have y. So we shall come here and have 3x and 5x. This is a positive, this is a positive, and this is a compute this. Now 3 plus 5, which is 8x, and then minus x squared. You may look at these as if they are similar terms, as if they are like terms, but in this case they are not. Why? Because they have different powers. So from here, we shall get 8x minus x squared. Where has y gone? Because 2 minus 2 is 0. You can't say 0 1. You can't say 0 votes. How many votes do you have? 0 votes. That is wrong. We shall simply neglect that one. It is no longer there. Remain with 8x minus x squared. Now, assuming that you have understood an explanation about direct terms, let us together try out this question. The question says, simplify the following, and part A is 2x squared y plus x squared y minus 3x squared y. Are these terms similar? Are they like terms? We are looking at this term having 2 as the coefficient. We are looking at this term having no coefficient in this case. And we are looking at this term having 3 as the coefficient. Is that a reason for us to look at these terms as if they are not similar terms or as if they are not unlike terms? I have said that the coefficients do not determine whether the terms are like or unlike. So the issue of coefficients is out. From there, we look at the variables. This is x, this is x, this is x, which means all these terms have got x in it. After that, we look at the type of that x. That x has got the coefficient of 2. That's the power of 2. X has the power of 2. This x has the power of 2. This x has the power of 2. So, looking at x alone, it means these terms are so far like terms. But we have not yet gone to y, so we cannot call them like terms on the basis of x. But as far as x is concerned, at the moment they are all like terms. After that, we go to y. This y has no power, this y has no power, this y has no power, which means the y's are also the same. So in that regard, therefore, all these terms are like terms. So after knowing that they are like terms, it means now the next is just simplifying. But I have said that it is always important to begin with the positive terms. So since this is a positive and this is a positive, the negative term is the one at the end. With this we shall simply simplify by looking at their coefficients. This is 2. Any term without the coefficient has the coefficient of 1, which means here there is a silent coefficient of 1. So in adding, we shall add 2 to 1 and then have 3x squared y minus 3x squared y. After that, we shall have to subtract these coefficients. The terms are the same, so we simply subtract the coefficients. 3 minus 3, what does it give us? It gives us a 0. Now, if we have got the coefficient as 0, does it mean that we shall now write x squared y, x squared y? Automatically no. When the coefficient is 0, then we neglect all the variables, and the final answer shall be 0. Let's look at another example, whereby we have 3u minus 2m plus 3m minus 4u. Here, we are going to have to identify the direct terms. This is 3u, this is 4u. Are they similar terms? Yes. Why? The variables are the same. So this will be 3u minus 4u. Remember, I have said every term comes with its sign. This form is a negative, so it will come as a negative. Then we come to these two. This is 2m, this is 3m, meaning they are like terms. Now this one is a negative, this one is a positive. And we have said it is always important for us to begin with a positive term. So in this case, we shall begin with 3m. That is 3m, and then minus 2m. After that, we simplify. This is 3, this is 4. I'm saying when we are simplifying like terms, don't really focus on their coefficients. So this is 3, this is 4. When we go to back integers, we have here positives and here negatives. How many positives are these? 3 of them. 1, 2, 3. How many negatives are these? 4 of them. These are positives, sorry. These are negatives. 1, 2, 3, and then 4. So these ones go together, these ones go together, these ones go together. This implies that our u is a negative, and it is 1, therefore it will be negative u. In this case, you don't try negative 1u, you integrate the coefficient and take the variable. So it will be negative u. Then we come to this. I've said it is important to always first work out the integers. This is a positive, this is a negative. Positive, 3 of them. 1, 2, 3. Negatives, 2 of them. 1, 2. So these ones go together. And then our result will be a positive. Since it is only m, we shall say the result will be negative u plus m. Negative u plus m. Let us have other terms which are in fractional form. Collecting like terms. Collecting like terms involving fractions. Let us this time look at collecting like terms involving fractions. And our first example here shall be simplify x out of 2 plus x out of 3. Simplify x out of 2 plus x out of 3. Now, in this case, this is x, this is x, but because these are fractions, we first compute the fractions and then after we shall look at the terms later. So this is a fraction, this is a fraction. We shall work out these ones the way we work out fractions using the LCM method. What's the LCM of 2 and 3? Our LCM in this case will be 6. So you shall have x out of 2 multiplied by 6 plus x out of 3 multiplied by 6, and then everything out of the LCM, which is 6. We cancel, 2 divided by 2, 1. 6 divided by 2 is gives us 3. 3 divided by 3 is gives us 1. And 6 divided by 3 is gives us 2. So it implies which is equal to, this is 3 times x, we begin with 3, and have 3x plus 2x out of 6. And then we shall add, these are like terms, so we shall add their coefficients and have 3 plus 2, which is 5x. And this will be out of 6. That will be our final answer. So example B, let's look at m plus 1 out of 4 plus 2m minus 3 out of 5. Now, in this case, what we need to look at is that this virtual or this line that covers m and 1, which represents division, is only on m and 1 out of 4. It doesn't cross up this side, which means this is a term alone, and this one is also a term alone. So when we are computing this, we have to consider this fraction alone and this fraction alone. But there are several ways of how we can answer this one, but it is important to remember that this m is out of 4 and this one is out of 4. In other words, m and 4 are to be divided by, m and 1 are to be divided by 4, 2m and 3 are to be divided by 5. So among the many methods we can choose to express each of the numerators at the fraction form and have m out of 4 plus 1 out of 4. Remember, if we are to compute this one, we say fraction with the same denominators can be added by retaining the denominator and adding the numerator. So if we are to compute this, we shall go back to this. So we shall take this and then we add there. This is 2m out of 5 minus 3 out of 5. So when we do it this way, it will be easier for us to compute. After that, we can now look for the LCM of all the denominators. Since this 4 is similar to this, we shall take 1. This 5 is similar to this, we shall take 1. So the LCM of 4 and 5, our LCM in this case will be 20. Hoping you remember how to find the LCM. So we shall have m out of 4 multiplied by 20, which is the LCM, plus 1 out of 4 multiplied by 20, which is the LCM, plus 2m out of 5 multiplied by 20, still our LCM, minus 3 out of 5 multiplied by 20, our LCM. After this, all the above will have to be divided by the LCM. After that, we compute. 4 divided by 4 is give us 1. 20 divided by 4 gives us 5. 4 divided by 4 gives us 1. 20 divided by 4 gives us 5. 5 divided by 5 gives us 1. 20 divided by 5 gives us 4. 5 divided by 5 gives us 1. 20 divided by 5 gives us 4. After this, we shall be having m multiplied by 5 plus 1 multiplied by 5 plus 2m multiplied by 4 minus 3 multiplied by 4, everything out of the LCM, which is 20. What is m times 5? This gives us 5m. 1 times 5 gives us 5. 2m times 4, we multiply the coefficients. 2 times 4 gives us 8. So that means this will be 8m minus 12 out of 20. Now when we reach here, we shall now easily collect like terms, which will be 5m plus 8m. This is 5m, this is 8m. They are like terms because they have the same variable. Then this is a positive, this is a negative, these are coefficients, they are also like terms. These are constants rather, they are also like terms. So we shall begin with the positive one, which is 5, and end the negative one, which is 12. And then everything will be out of 20. So we add the coefficients. What is 5 plus 8? This gives us 13, and that is 13m. Now we come here. This is a 5, which is a positive. This is 12, which is a negative. If we are to use our mapping method of positives and negatives, 5 are positives, 1, 2, 3, 4, 5. 12 are negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these ones go together, these ones go together, these ones go together, these ones go together, these ones go together. So we count the remaining ones. The remaining ones are 1, 2, 3, 4, 5, 6, and 7, which are negative, which means here it will be minus 7 out of 20. So can we simplify this? Definitely no, because these terms are unlike, so we cannot subtract 7 from 13m since they are unlike terms. So we shall leave our answer like this. Hoping you have understood how to collect like terms. I wish you a nice evening. Thank you for being good learners. Keep safe, keep at home as we wait to see each other once again. You help me and work out this activity. Thank you so much.